Part 3 of the Introduction to Amateur Astronomy lecture series is entitled Binocular Basics. So yes, last time with part 2, we talked about everything you can see in the sky with your eyes alone. We learned how to navigate the sky with nothing but a star map, and we talked about eclipses, aurora, meteor showers, and so on that you can view with just your eyes alone. And so once you learn the night sky with just your eyes, the next step is, again, not to get a telescope. The next step is to learn to navigate the sky with binoculars. Yes, binoculars. They are often underestimated and unappreciated by beginners fixated on the idea of getting a telescope. And when I mention to people getting started, try navigating the sky with binoculars first, and they ask, binoculars? I never thought of that before, because they don't think of binoculars as a telescope. They think of them, as binoculars. But guess what? Binoculars are telescopes. They're just two of them put together. So again, binoculars make the ideal starter instrument. Basically, they fill the gap between the unaided eye and a telescope in terms of power, field of view, and convenience. So for example, with just your eyes alone, you can see about 100 to 120 degrees of the sky with, again, your unaided eye, which is a pretty wide field of view. But with a telescope, at least with your typical amateur telescope, like say an 8-inch Schmidt-Cassegrain or something like that, you can see no more than a degree of the sky or less, depending on the focal length of the telescope. Definitely, some telescopes can give wider fields of view than this, but most telescopes don't. Now, binoculars, at least your typical pair of binoculars, they give you a field of view between 5 and 7 degrees, but it depends on the binocular that you're using. There are some binoculars that are, just give a field of view of maybe 2 to 3 degrees, really big binoculars. But there are some binoculars, like say 2x54s, and if you don't know what those numbers mean, more on that later, but 2x54s can give fields of view of 36 degrees. And you might wonder what 2x54 binoculars are good for with such a wide field of view, but they are really great to look at fainter stars in constellations. But again, binoculars fill the gap between your unaided eye and a telescope. Now, I always like to mention books. I know people don't like books today because they take up space in their home. They just like to get stuff on their smartphone or iPad or their computer, but books are still the best resource for new information. And so I'll just mention half a dozen great books here. So I'll mention first, Stargazing with Binoculars, which is in the 4th edition, came out last in 2014. And of course, it'll cover a lot of what I cover today, but in, of course, more detail because it's a book. So they'll cover stuff like how to choose binoculars, how to set up and use binoculars, and it also provides a month-by-month guide to the best objects in the sky. It also gives you advice on mounts and tripods and other accessories. But then on the right side here, we have binocular highlights. And that is from Sky and Telescope, and it's currently in its 2nd edition. And that again gives you advice on choosing a pair of binoculars for stargazing. It gives you 109 celestial sights for binocular users and provides observing tips. But then there's this book here, Turn Left at Orion, which is one of the best-selling amateur astronomy books of all time. It's currently in the 5th edition. And the one thing I really like about it is it comes spiral bound. So if you take it out in the field with you and open it to a chart, it stays open, which your typical book binding doesn't do. But Turn Left at Orion is spiral bound. And it's mainly for the telescope, of course, because you see telescopes here on the cover. But I guarantee you pretty much every object listed in Turn Left at Orion can be seen in binoculars. And as we'll discuss later, if you can find it with binoculars first, it'll be much easier with a telescope. So it does contain info to locate planets and nearly 100 deep sky objects. And of course, the heart of the book is the maps and large format drawings that accurately depict views through a telescope. So they you know, the drawings won't really depict what you might see in binoculars, but they will show you what it looks like through a telescope. So it is a great book. And here are just a few more. We have Binocular Astronomy, which was last released in 2014 with the second edition, I believe. This gives an in-depth description of, again, choosing, testing, and buying equipment. That's, of course, mandatory. There's details of care and maintenance and mounting binoculars. And it lists, of course, the most exciting objects for 50 and 100 millimeter binoculars, and it's complete with finder charts. And then we have Touring the Universe Through Binoculars by noted author Philip Harrington, who also wrote a great book called Starware, which is all about equipment reviews and stuff like that. I don't know when the last version came out, but Starware is a pretty good book for the equipment junkie as well. And so the last edition came out some time ago, about 1990, but it's still relevant for today. It has a section on exploring the solar system, where it talks about observing the moon, planets, asteroids, meteors, comets, and the sun with binoculars, but of course, stars and deep sky objects. And the final chapter includes a detailed atlas of deep sky objects. And in the back of the book, in the appendices, it includes guidance on how to buy, care for, maintain astronomical binoculars, and tips and hints on using them, and detailed information on several homemade binocular mounts as well, which we'll get into today. And then finally, we have Binocular Stargazing, which last came out in 2005. And that includes a complete guide to current binocular brands and models. But if that's so, you know, it's pretty old. So who knows how good the information then there is. It includes a guide to viewing the stars, moon, planets, meteors, comets, and even aurora through binoculars. I've never tried to view aurora with binoculars before, but try it. And so it explains, you know, what deep sky objects to look for in each season. So there's a half dozen books that are really great for the binocular user. So let's talk about the benefits of binoculars. Of course, the biggest benefit is they are really simple to use. When you buy a pair of binoculars, you basically take them right out of the box, take the dust caps off, and they are ready to go. So there's no assembly or no special alignment. If you do drop your binoculars and lose the alignment between the lenses, you're probably better off buying a new pair, because it's pretty expensive to send them in and get them realigned and all that sort of thing. So, you know, be sure not to drop them. But they are very easy to use. And the images are right side up and in front of you. You have no idea, as a longtime amateur astronomer, how many times I've heard people complain, you know, beginners complain that, oh, my telescope gives me a mirror image. My telescope shows me everything upside down. How can I correct for that? And pretty much every seasoned amateur astronomer will tell them the same thing, is basically get over it. Because, you know, of course, telescopes can be corrected, but it degrades the images of things we see in the sky. But with binoculars, it gives you a right side up image, and so it's much easier to learn to navigate the sky with binoculars. And of course, two eyes are better than one. It's been said that observing with two eyes allows you to see 40% more, or like, you know, 40% brighter or more vivid or something like that, because your brain is used to working with two eyes. So binoculars are always used with two eyes, so your brain is happy when using binoculars. And it might get a little confused when you're peeping through an eyepiece with a telescope with just one eye. Binoculars, compared to telescopes, as mentioned, have a large field of view and makes objects easy to find. So they are a great way to learn your way around the sky, you know, with an instrument. And of course, they're incredibly portable. They basically make for grab and go astronomy. So here's an example. Let's say it's Sunday night and it's clear, but you've had a very busy weekend with friends or family, and you have to get up for work early the next morning. But currently outside, there's a really close conjunction of the moon and Venus. Now, last time with part 2, I mentioned how planetary conjunctions like this can be enjoyable with the naked eye, and they certainly are. But perhaps you want to get a closer view and you don't have the time or energy to haul out your telescope. So you grab your binoculars, and this is the sight you will see. Here we have the waxing crescent moon, or as it is known, the old moon in the new moon's arms. What's going on here is sunlight reflects off this portion of the moon to us on Earth. However, this area of the moon is not currently receiving direct sunlight, but a portion of sunlight reflects off Earth and onto the unilluminated portion of the moon. This is called, appropriately enough, Earthshine. And of course, it looks much more vivid in binoculars. And you can see Venus nearby, which is always a pleasing sight with your eyes, and especially through a pair of binoculars. And kind of as alluded to, with binoculars, you gain observing and chart reading skills. So last time I talked about star hopping, how you move basically from star to star, like, using the pointer stars to find Polaris, or using the handle of the Big Dipper to follow the arc to Arcturus. That's star hopping. And you use the exact same technique to track down deep sky objects with binoculars. I mean, yeah, a lot of people buy go-to telescopes today, which is fine. But if you really want to learn the night sky, it's great to find these objects for the first time on your own. It's more fulfilling, and you'll learn the sky more intimately, and you'll find yourself drawn more to amateur astronomy. So binoculars, again, give you these chart reading skills. If you can star hop with binoculars, you can star hop with a telescope. So let me talk about some great star charts or star atlases that you can use with binoculars. My favorite is Sky and Telescope's Pocket Sky Atlas. They have a regular size version, which is like a little bit bigger than, say, a paperback book, but they came out with a jumbo version some time ago, which is a little bit bigger and easier to read at night compared to the smaller version. So the Pocket Sky Atlas contains 80 charts. I'm going through a little slideshow here of the 4 that Sky and Telescope provides on their website. But so this is 4 of the 80 charts that are provided. And it has more than 30,000 stars individually sized according to their apparent magnitude, their brightness as seen from Earth. And it has 1,500 deep sky objects color-coded by type, including 675 galaxies oriented as they are in the sky, but that's really more for a telescope than it is binoculars. And in addition to the 80 charts, there are 10 close-up charts, like, say, this one here. So here's a close-up chart of the Pleiades, and this is very comparable to how the Pleiades will look through binoculars, as we'll see later. So you can tell which star is which in the Pleiades. You can name the Pleiades or identify the Pleiades, because that's what we call the individual stars in the Pleiades. And then if you want a more broad shortcut, there's Sky and Telescope's Messier card, and they also have a Caldwell card. Now, both cards, they're laminated, of course, which is a must here in Michigan because it's very dewy. But both cards list 109 objects, because Sky and Telescope goes by the idea or the opinion, really, that there are only 109 objects in the Messier catalog. More on that later. So it does not list M102 because many consider M102 a duplicate of M101. But again, I'll come back to that later. And on the back side of each chart, it gives the NGC or IC numbers along with their Messier or Caldwell number. But if you don't know what NGC or IC numbers on, again, more on that later. But another favorite are these little handy flip charts from skyspot.com. They're really great. So they have several, but of course, probably the most common ones that are purchased are the Messier objects, which is a 2-volume set, which you buy 2 for about $36. And they contain about 106 charts. They also do not list M102, and M31 and M32, which are M31 is the Andromeda galaxy, M32 is a satellite galaxy. They are listed together. And they also include a chart of the famous Virgo cluster of galaxies. Now, this little target here is called a Telrad site. So these charts are specifically meant to use with a telescope that is equipped with a Telrad finder. Now, if you don't know what a Telrad finder is, more on that in part 4. But even though these are meant for Telrad finders, they are great for binoculars. And again, they are laminated. I have a link to these in the notes. So be sure you check the part 3 notes. And toward the back of the notes, there's a link to these. And again, it's at sky-spot.com. They are great. I highly recommend them. So binoculars also make a cheap first investment. Basically, for what you pay for a junky department store telescope, like maybe $100 or so, you can buy a really good pair of binoculars. So if you're really limited, or don't want to spend more than $100, $150 on your first telescope, well, don't do it. Spend $100 or $150 on a good pair of binoculars. You'll be much, much happier that way, because there's no good telescope for less than, say, $200, at least in my opinion. And I'll basically state that as a fact. There are no good binoculars or telescopes less than $200. And of course, as you probably well know, binoculars are very versatile. Again, most people don't even think they're good for astronomy because they're meant for other things usually. But of course, they are great for astronomy. So of course, besides astronomy, they can be used for bird watching. Isn't he cute? Or maybe you're up in the cheap seats at a baseball game. So if you're way up in the nosebleed section, you can use binoculars to get a closer look at the action. Maybe someone's stealing home and you're way back here, but with binoculars, you get closer to the action. And of course, if you are so inclined, if you're that type of person, you can use them at the beach. Now, of course, there is a warning here. If you do this, you may end up eating your binoculars or perhaps being hit with your binoculars. So I don't really recommend that. Okay, let's get serious here. So here are the binocular types. Compared to telescopes, this is really easy because there are basically 2 types of binoculars. The first type are poral prism binoculars because inside they use poral prisms to give you a corrected image. So poral prism binoculars are the most common style binoculars, period, and they are the most common style for astronomy. They are the most widely seen binoculars out there. And they are less expensive than the next type, which are roof prism binoculars. So of course, roof prism binoculars use roof prisms to give a corrected image when you view through them. So the advantage of roof prism binoculars is they are more compact than poral prism binoculars. There are many like say, 6x32 binoculars or 6x20 or something like that you can fold up and stick in your pocket. So that's the advantage to roof prism binoculars, really, is they're more streamlined, they're more compact, and a little more portable. But compared to image quality, which is what really counts, there's no big difference between poral prism and roof prism binoculars. That's why, at least out in the field, I see most people using poral prism binoculars. Because again, in terms of quality of views, there's really no big difference between one or the other. And there is kind of a quasi third type called image stabilizing binoculars, but all image stabilizing binoculars are roof prism binoculars. But what makes them different is inside they have a gyroscope or liquid filled prisms that keep the image still with the push of a button. And these were basically invented for people that are on like boats, like rowboats or pontoons or something like that, where the water's bobbing you up and down, and the image stabilizing binoculars help correct for that. They're great for eclipse chasers that are on like a cruise ship, because you can't really bring a hefty tripod or anything with you. So they have many non-astronomy uses, but what's great is if you do go out for quick views and don't even have time to put your binoculars on a tripod, you can just push the button and instantly the image is stable. Of course, the disadvantage is they are pretty expensive. There are several models available, and I'll list the ones from Canon here. I know there are other image stabilizing binoculars out there, but Canon came out with the first back in the 2000s. And the ones that are great for astronomy are 10 by 42s, 12 by 36s, 15 by 50s, and 18 by 50s. Again, if you can't write that down, check the notes. It's in there. All right, so let's help you choose a good pair of binoculars. The first thing we'll talk about is their power or their magnification. When you talk about, say, 7 by 50 binoculars, the first number is the power, the magnification. So 7 by 50 binoculars magnify 7 times. And so for handheld astronomy, for holding the binoculars with your hands alone, it's best to use something between 7 and 10 power. But there are age considerations, as I'll come back to, because it depends on, on your age, what type you should get. Now, the next number, like say 7 by 50, the 50 is the aperture of the binoculars, the diameter of the lenses in millimeters. So, of course, when it comes to astronomy, bigger the better. The larger the lens or lenses, the more light you let in, and the brighter and sharper things will be. It's the same thing with telescopes, as we'll get into in more detail next time. But when it comes to binoculars, bigger is better only to a certain point, because as they get really big, they get hard to hold with just your hands alone. And again, the advice here is for handheld binoculars. So when it comes to that, we often consider 50 millimeters the maximum for handheld views. So maybe I should say 50 millimeter maximum. That doesn't, so yeah, that probably makes more sense. So that means for handheld binoculars, most people recommend 7 by 50 or 10 by 50. But again, it depends on your age, because as you age, your pupils don't dilate as wide as they used to. So if you use, if you're like over 50, like I am now, I just turned 50 last July. You don't have to welcome me on that. I'm trying to forget it. But once you get maybe over 50 or so, your pupils don't dilate wide enough to take advantage of the exit pupil of 7 by 50 binoculars. So here's how you calculate the exit pupil of your binoculars. If you use 7 by 50, you do 50 divided by 70. And so that works out to be 7.1. And if your eyes only dilate to like 5 millimeters, then you're losing light. You're not getting all the light that the binoculars use if you have 7 by 50. But with 10 by 50, it's, 50 divided by 10, which is 5. So if your eyes only dilate to 5 millimeters, you take full advantage of the light collected by 10 by 50 binoculars. So if you're younger than 50, get some 7 by 50s. If you're over 50, get 10 by 50 binoculars. And of course, another important factor is field of view. And of course, when it comes to this, wider the better as well, because of course, the more of the sky you can see, the better the view is really, and it makes stuff easier to find. So most 10 by 50 binoculars have a 5-degree field of view, but there are some ultra wide binoculars, and kind of a caution with these, if they're low priced, less than say a few $100s, the outer edges of the field of view will probably give distorted stars. I have some 10 by 50 ultra view Orion binoculars, and they're sharp to about 75% of the way from the center. So 25% of the field is kind of fuzzy. But if they're really high-end binoculars, that costs many hundreds of dollars, they're probably really, really good. But again, most 10 by 50s have 5-degree fields of view, but not all of them. And then again, most 7 by 50 have 7-degree fields of view. So yeah, if you're older, you lose a couple of degrees, but the quality of the view is sharper and brighter for you. Now, all binoculars have some form of anti-reflection coating today, because yeah, lenses are supposed to pass the light through. They're supposed to let light through, but even lenses reflect some of the light away. But what the anti-reflection coatings do is they make the glass more transparent. They transmit more of the light to your eyes instead of reflecting it away. And of course, for astronomy, it's really important because everything we look at in the sky is usually pretty faint, except for, of course, the sun with a proper filter and the moon and planets. Everything else is kind of faint. So you want to let as much light through as possible for astronomy. During the day, no big deal. You got lots of sunlight, everything's bright and vivid, but at night, not so much. So all the anti-reflection coatings are magnesium fluoride, and you can usually identify the coatings with a purple, green, or amber color. Now with binoculars, I've only seen purple and green coatings. I've never seen amber coated binoculars, but I have seen amber coated eyepieces. I do not believe there's any advantage to the colors of the coatings. People often ask that. So it doesn't really matter if it's purple, green, or amber. The important part is it has optical coatings to make the glass as transparent as possible. Now, there are ruby coated binoculars. These you want to avoid. So do not use ruby coated binoculars for astronomy. These are meant for glare reduction. So if you're looking over a bright snowy field or a lake that reflects a lot of sunlight, these are meant to reduce glare under those circumstances. But of course, they're bad for astronomy because they dim the light that comes into them. So again, no ruby coated binoculars. Don't buy them for astronomy. And binoculars do have different glass types. There's BK7s, or borosilicate crown glass. This is the lower end type. So you really want to look for binoculars that have the BAK or barium light crown glass. So this is the preferred type because it's much better for light transmission and image quality. So get yourself some 10 by 50 or 7 by 50 binoculars with the BAK4 type glass. And of course, there are different focusing styles. Pretty much all 7 by 50 or 10 by 50 binoculars, or any close variation thereof, will have a center focus. You spin a little wheel, the eyepieces move in and out, and they both focus at the same time. So most binoculars are center focus binoculars. But when you get bigger than, say, 20 by 80 binoculars, they have an individual focus. So I know for certain that 25 by 100 binoculars are individual focus. So you turn both eyepieces individually to get a focus. And one often overlooked focus is the diopter adjustment. So this is on the right eyepiece of your binoculars. So of course, here's the left eyepiece, which is out of the field view, and this is the right eyepiece that you look through with your right eye. So you see this little scale here. So your left eye and your right eye might not come to the same focus. They might be a little different. So what you do is you focus with the center focus, and this would be the center focus here, this little wheel here. So once you get it focused, you can cover up the left side of your binocular and just look to the right side. And you might notice the focus is a bit off. And then you just tweak the focus here. The good thing is you only have to do it once. if you share binoculars, I doubt the person you're sharing them with will take the time to change the diopter adjustment. But really, once you set this, you don't really have to change it unless you shift it by accident. So again, there are weight considerations. So binoculars that are too heavy are too hard to hold steady. So to reemphasize, for handheld astronomy, we recommend 7x50 or 10x50 binoculars. Now, there are 8x56s. Those would be pretty good. You get a little more aperture and a little more magnification than 7x50s. And those can be held steady. And if you're a pretty strong person, you do your push-ups every day, there are 9x63 binoculars that you could probably hold steady as well. It depends on the person, really. So, but just, don't get binoculars that are too heavy to hold steady, unless they're image stabilizing binoculars, and then, that corrects for itself. But they are really, really expensive. And here are just a list of some of the recommended brand names. There are, of course, many, many others than the ones listed here. If you are made of money, you got lots and lots of money, get yourself some Zeiss binoculars. Damn, are they good. But man, are they really, really expensive. But these are all really affordable. And they give really, really good views. Not as good as Zeiss binoculars, but you don't have to sell your firstborn to get a pair. So here are some recommended places to buy. And pretty much all of these are telescope dealers as well. So, it's a good place to start purchasing, stuff in the future with your telescope. You can buy some binoculars from one of these places first. And again, all these links are in the notes. So don't feel, am I supposed to write all these down? Nope, they're in the notes. But I should mention here with Orion telescopes and binoculars, if you decide to buy some binoculars from them today, do it through our website. Because if you go to the Support Us menu, you can go to Orion Telescopes and Binoculars website. And if you purchase something through our link, we get a commission. So awesome. Now, what do you do if you find some binoculars? Now, odds are you'll buy some online and have them shipped to you. Here in Kalamazoo, there's not really any good place to buy binoculars. There is Norman Camera, but they sell the really pricey ones, that cost more than they should. So most of you will buy binoculars online. So make sure you can return them, if you're not happy with them. Make sure they're not discontinued or close out or something like that, where once you buy them, that's it. Make sure you can take them back if you're not happy with them. So when you do get them in the mail or you inspect them in the store, if you're lucky enough, inspect the workmanship. Usually, as soon as you pick up a pair of binoculars, you can tell if they're good quality. When you hold them and maybe shift the angle, the separation of the eyepieces, see if there's any flexure in the joints. Or of course, give them a little jiggle. If you hear a little bit of rattle inside, that means the prisms are probably loose, and don't buy them. The hinges should work smoothly with steady resistance. They should hold their separation, their eyepiece separation, when you adjust them for your eyes. You don't want them to slip out of place. Check the focus. Is the focus smooth? How much do the eyepieces tilt when you focus? If they tilt a lot, or really just a little bit, it depends. You want to reject those pairs. So the focus should be smooth. Of course, inspect the optics and the coatings. If you buy them from the store, people may have looked at them before. So if there's a little bit of dust on the outside, don't worry about that. A little bit of dust on the lenses is fine. It will not affect the image quality. But of course, look on the inside. If you see any dust or mildew or debris inside, something happened to them, and you don't want those. And of course, you want to look at the coatings. Now, there are different scales to the coatings. There's multi-coated and fully multi-coated. What is the difference? The difference is multi-coated is not coated on every single surface, not both sides of the lenses or not on all prism surfaces, but fully multi-coated is coated on both sides and every surface everywhere. And that can be kind of hard to tell for a beginner, but as you let light, shine into the binoculars, you should see that purple or green coating on the inside and the outside. It's usually pretty easy to figure it out after a while. And of course, check the eyepieces and exit pupils. Hold up the binoculars, at arm's length. The exit pupils, where the light comes out through the eyepiece, it should be round and uniform in brightness. If you see any cutoff, if the exit pupil is square, that means the prisms are cutting off some of the light. So you want to reject those. The exit pupil should be round. And of course, look through them. During the day, this is difficult. So if you can, test them out at night. If you bought them, say, online, you can look at some stars. They might have a little bit of false color. They might have a little bit of purple glow around them, at least for the brighter objects like the moon or bright stars or planets. But otherwise, the stars should be pretty sharp across the entire field, unless they're low-end, low-end binoculars. I lost my train of thought there. But usually you can tell when the optics are good. And make sure they're in collimation too. If you see a double image, that means they're out of collimation, or your brain is kind of struggling to form a single image. A good thing to do is to hold the binoculars away from your eyes and slowly move them in, and you shouldn't see the images merge together, or they should merge together at least really fast. And again, I have more information of testing these in the notes. And, it goes without saying, but compare prices. You should always compare prices. But usually when it comes to stuff like this in astronomy, the different astronomy dealers and so on, the prices are pretty uniform, but sometimes you're surprised. All right, so here are some observing tips for binoculars. So yeah, using binoculars handheld is great, but to take full advantage of binoculars, it's ultimately best to mount them eventually. Or you can at least observe binoculars from a lawn chair, a reclining lawn chair. You could do it handheld and support your arms on the armrest here. But here's one great little gadget you can buy called the Manfrotto Magic Arm. These sell for about $146 as of 2022. Prices change with time. And so this is the magic arm part here. And then you have to purchase this part separately, or some of them come as kits. This is called the super clamp from Manfrotto. And this is another $36. So you can see we have the super clamp on the chair. It looks like they may have installed a little extra width to the bar there. So you might have to do something like that. And then you have the magic arm here, and the binoculars are held nice and steady. So that's one thing you can do, but there are many, many others. So pretty much any binoculars you buy, like especially 7x50 or 10x50, should have a little plastic cap. Usually the binocular manufacturer has their logo here, but Orion was good enough to have a little picture of a tripod here. So this tells you, if you take this little cap off, that's where the thread is for a binocular tripod adapter, or a L adapter like this one. So mounting binoculars is fantastic because, number one, it gives you relief from strain of holding the binoculars during prolonged observing sessions, and helps to reduce fatigue, because if you're holding binoculars, for over an hour or more, you get tired of holding them up to the sky. So mounting binoculars takes away that strain. And of course, the quality of the views are increased. You're able to see more and fainter detail when binoculars are mounted, since they're being held steady. Mounted binoculars also maintain their position, permitting referencing a star atlas. So if you're trying to find a deep sky object in the sky with a chart, with handheld binoculars, you might lose your place in the sky. So if the binoculars are being mounted steady on a tripod, then they're being held steady. And you could check where the object is located on your star atlas. And of course, mounted binoculars make it easier to share views with friends, family, or the public. Because, with handheld binoculars, you're trying to tell the person, no, look here, no, look up there, look down there, and so on, but with mounted binoculars, you can all share the view. So here's the old school L binoculars. So this part threads into your binocular. This part threads onto the tripod. Any camera tripod will do. Some of these L adapters are fancy now, like this one. They have this nice little curve to it. And of course, make sure they're metal, not plastic. I have seen cheap ones that are plastic and aren't very steady. There's too much flexure in them. But metal ones are nice and sturdy. Now, if your binoculars do not have a thread, then you can buy one of these universal adapters. I have one of these because my 7x50 binoculars, which I'm probably too old for now, do not have a thread in the front. So I have to mount it on one of these little contraptions here. And, like Bushnell sells some. I think the one that I got is from Bushnell. Usually you think of them as a kind of low end, but, the binocular adapter is just fine. But what's really bad about tripod mounted binoculars is looking at the zenith. I mean, you could get the tripod as high as you can, but still, you really have to crank your neck at the zenith to look through these things. So that's where parallelogram mounts come into play. They make it a little more comfortable to look at the zenith, and they're much more capable that way. But the real advantage of parallelogram mounts is it allows you to mount binoculars larger than 7x50 or 10x50. These can work with 20x80s, 25x100s, or larger, depending on how bulky the parallelogram mounts are. So these are a couple of models from Orion. I forget the manufacturer of these guys here. I forgot to make note of this, but as I recall, they are really expensive. So parallelogram mounts are great. You can see they have a counterweight. So again, they allow you to move on to much larger binoculars, because you might wonder, well, heck, I'm just going to move on to a telescope. But I've known many amateurs that only use binoculars. They have no interest in using the telescope, for their own reasoning. So many use a parallelogram mount for those that never want to get a telescope. Some don't. That's fine. So just to mention this, if you are a Kalamazoo Astronomical Society member, and of course, if you live in the area, we have these binoculars available for loan. So we have a pair of Orion 25x100 binoculars on their monster parallelogram mount that, if you remember, you could check out today. And they are great. We have the pier extension. So if you're 6 feet or taller, the pier extension is really mandatory. But if you're a do-it-yourself kind of person, you could build your own parallelogram mount. You can see some people do use your standard camera tripod, but they build their parallelogram mount. Or some people use crutches, unused crutches as their tripod. And you can use, barbell weights, or you can just fill a little jug with water or sand for your weight. The great thing about doing this is if you have too much weight, you can just dump some of the sand or water out, or you can add more if you need to. So in many of the books that I mentioned early on, they have plans to build some of these, but in the notes, I've given you links to websites that have designs to build your own parallelogram mount. And if you do build one because of this series, send me a picture. I'd love to see it. Now, this is not a parallelogram mount, but it is, of course, a binocular mount. And Peterson Engineering has created this easy binocular mount kit. And it doesn't come with everything you need. It comes with, all the stuff shown in the picture here, but there is some stuff you have to go to your local hardware store to purchase. But they have a detailed list of what you have to buy and a detailed list of what you need to or how to put this thing together. So again, with a easy binocular mount or with a parallelogram mount, you can see you can even use them from the reclined position there, or the seated position. So speaking of the seated position, you could get yourself a binocular chair, or really build yourself a binocular chair, because as far as I know, there's nowhere you could buy one of these things. There was one you could buy from Astro Gizmos called the Easy Gazer, but as far as I know, they don't make that anymore, but I still listed in the notes just for reference purposes. But they said they couldn't get the chair that they needed anymore, but there are other beach chairs out there. So that's all you need. You just get yourself a beach chair, and this is set up on a Lazy Susan, so you can sit in this and spin around and adjust the mount here to look at different things in the sky. This one is from Rob Nabholz, who has a great website called Astronomy Projects, where you can build all kinds of stuff. And one of these is this binocular chair. Just the only disadvantage is it's not very portable. But if you live somewhere where you have good skies, lucky you, you could, try building one of these. Looks like it even has a little spot to keep charts in, or even your binoculars. But these are great. I've seen these before, and these are a lot of fun to use. You just got to build one, because there's nowhere to buy one of those. But here is the ultimate binocular chair. This thing just looks insanely cool. This is the Star Chair 3000. These were really big fixtures in sky and telescope and astronomy, quite some time ago, but they haven't built these things since at least 2009. I've heard rumors that they might come back, but I doubt it. But when these things were sold, they cost about $6,100. I don't even think they're go-to. You just use the little joystick here to move yourself around the sky. You would think was for $6,000, it would at least be computerized, but as far as I knew, they were not. But boy, would I love to try one of these things out. And speaking of the binoculars here, I just want to mention these. Those are Fujinon 25 by 150 binoculars. So 25 means they magnify 25 times, and 150 means they have lenses 150 millimeters across. That is 6 inches. So these are basically two 6-inch refractors, two refracting telescopes right next to each other. And they are awesome, but they cost about $6,500. So between the chair and the binoculars, we're looking at probably over $13,000 right here. So these are great. These binoculars only have a field of view of 2.7 degrees, but that was enough to let Yuji Hyakutake discover his bright comet Hyakutake, in January of 1996, that put on a great show just 2 months later. But he did not have a Star Chair 3000. He had his mounted on a large binocular mount, a really big binocular mount. But yeah, these are really, really good binoculars, but they are really expensive. But of course, you can build your own binocular chair that's much more sophisticated. Here's a homemade motorized binocular chair using twin 6-inch reflecting telescope. So instead of lenses with your typical binoculars, these have mirrors instead of lenses. And the scope can be raised and lowered as the observer raises and lowers their heads. The whole chair turns and reclines at the observer's command, thanks to a little hand control paddle that you can kind of see sitting in the chair there. So yep, somebody built these. But these are not go-to like the Star Chair 3000. If you want go-to, you can build one of these things. So this gentleman here is Norm Butler. And this is his go-to binocular chair, which has a 40,000 object database. Because what he did is he cannibalized, the dual servo motor drive from a Celestron Nexstar 4SE telescope, or mount. So he basically cannibalized parts from a go-to telescope mount and built this binocular chair. This was featured in Sky and Telescope in July of 2012. So if you have that issue archived, you can dig it up and find out how he built this thing, because it's fully go-to. Now this is also very innovative. This is the sky window, which is a downward looking binocular mount. These were Sky and Telescope. This was a Sky and Telescope hot product some time ago, like, boy, 20 years ago now or so. And unfortunately, the sky window is no longer produced, but you might be able to find them listed as used from time to time. They were made by Trico Machine Products, and they could use binoculars as large as 20 by 80s. But of course, you can build your own. So here again is Rob Nabholz's downward looking binocular mount. I got this from his website. And again, I have Rob Nabholz's website linked in the notes. So if you want to learn more about this, you can go to his website and check it out and build your own downward looking binocular mount like this one. So this way, if you do have neck issues, you don't have to bend your neck to look up to the sky at all. So some people prefer this, including KAS member Joe Comiskey. So he built his own downward looking binocular mount, and this is the original configuration. He has since modified it. You can see the current version in the notes because he's since changed it a little bit. But what he did here is the mirror is a special type of mirror called a first surface mirror. So it's more reflective that way. It's much better than your quality, bathroom mirror, which is what he used at first. But once he upgraded to a first surface mirror, there was an instant increase in quality. So now let's move on to all the wonderful targets you can see and experience with binoculars. We'll begin with everything you can see in our solar system with binoculars. And we'll start with none other than the sun. So of course, you definitely need protection here. You can't just use your binoculars alone, but we'll come back to that. But with binoculars, with properly filtered binoculars, you can look at the sun and check out the current batch of sunspots, if any. So here's a great day for solar activity. These would look really, really good in binoculars. Or of course, you can observe the partial stages of a total solar eclipse or an annular eclipse, or just the partial phases of a partial solar eclipse. So that works too. But again, obviously, with solar viewing, you need special protection. So with your ordinary pair of binoculars, you have to get yourself a pair of solar filters that fit over the front of your binoculars. So what happens here is when you use these, they block out 99.999% of the visible light, 100% of the infrared light, and 100% of the ultraviolet light, and they make the sun extremely safe to view with binoculars. It's the same thing with the solar filter for a telescope, and we'll talk about that again next time as well. Now, there are binoculars that are called sunoculars from Lunt Solar Systems that are made to look at nothing but binoculars. They have these pair here, a pair of 8x32 binoculars that cost between $95 to $100. It's kind of weird. The black ones cost $95, but the color versions like red or yellow, they cost $100. So you got to pay $5 more for a pair of binoculars or sunoculars with color. I have the black pair, but the really good news is I didn't pay a dime for them. I won them, which is really, really amazing. It's the only thing I ever won that I actually use. And then they have a pair of 6x30 binoculars, and these only cost $20. So if you don't want to pay $95, at least, for one of these, everyone should have one of these $20 pair of binoculars because they are great for the next eclipse, So you can view the partial stages of a partial solar or annular eclipse. They're fantastic. The only thing I've discovered with sunoculars is when the sun is the only thing you can see, it's actually kind of hard to find at first. The first time I used my binoculars, I actually had a hard time finding the sun in the sky. It was more challenging than I thought. But of course, during totality, during the brief minutes of totality of a total solar eclipse, you can take the filters off and look at the solar corona. It is completely safe. It's actually much easier on your eyes than looking at, say, a full moon. But remember, as soon as you see like the diamond ring effect, it's time to look away and put your solar filters back on. So there is a slight bit of risk there, but as long as you're careful, you'll be fine. But with that said, for the 2017 eclipse, I did bring some 20 by 80s that I meant to look at totality with, but during the excitement, I completely forgot they were even there. I never looked through them. Even though I dragged them all over the country with me, I totally forgot to look through them. And then there's the moon. So of course the moon is really fun to explore with binoculars first before you ever look at it with the telescope. You can explore and learn all the lunar maria, or the mare. Maria is plural, mare is singular. So a mare is the vast flat volcanic plains in the northern part of the moon. And of course, you can identify craters and mountain ranges as the face of the moon changes as it goes through, its stately set of phases every month. So the moon is a lot of fun to explore. No special filter is required. And of course, you can get a better view of the planets than you can with just your eyes alone. So for example, Mercury. Now, Mercury, the innermost planet, it never strays further than roughly 28 degrees from the sun. So you can only see Mercury in the light of dusk or dawn. And even though Mercury can reach like a -1 magnitude, it can be pretty difficult to spot with your eyes alone. So binoculars make spotting Mercury much easier. So if you're not quite sure if you're seeing it, look at it with binoculars and it'll be a little more obvious. It might not be a disc through 7x50 binoculars, but through larger binoculars it might. And then of course with Venus, the crescent phase will be visible in fairly high power binoculars, but really not too much. If they're held steady, you should be able to do it in 7x50 or 10x50, because some people can see the crescent with their eyes alone if they have extraordinary vision. So definitely 20x80s should show the crescent phase of Venus very plainly with binoculars. Now, what about Mars? Now, sorry, it'll always appear as a bright orange star with binoculars, but of course, if Mars is in conjunction with the moon, or if Mars is near like an open cluster, like say the Beehive, then it looks great in binoculars, when you can view Mars together with another object, but by itself, it's just a bright orange star. Jupiter is one of the great highlights in binoculars. You really can't make out the belts and zones in binoculars unless they're fairly high power, like 20x80s or larger. But what you can do is you can watch the 4 Galilean moons, the 4 Galilean satellites, change in position over the course of maybe several hours, or definitely from night to night. Of course, when Io and Europa are close to Jupiter, they'll be hard to see. The only time you can see Io and Europa is when they're at their greatest elongation from Jupiter. The separation between Io and Europa and Jupiter is at its largest. And then you can see them through binoculars. Now, Saturn, you need at least 30 power to see the rings. So pretty much most binoculars can't do it. You could probably do it with the Fujinon binoculars, those 25x150 binoculars, but of course you can do it much cheaper than that. But you really need at least 30 power to see the rings. With larger binoculars, maybe 15x70s, maybe 10x50s, you should be able to spot Titan, again, when it's furthest from Saturn. but it is doable. But again, Saturn can be maybe near the moon or near a star cluster, and that makes it a great sight to view in binoculars. As mentioned, every 10 years or so, on average, we get a bright comet that you can see with your eyes alone. Remember, in July 2020, comet Neowise was, visible to the naked eye, but it was a much better sight in binoculars. With our club's 25 by 100 binoculars, they were an extraordinary sight. Boy, were they awesome through 25 by 100 binoculars. But, just because it's not visible to the naked eye doesn't mean you can't see it in binoculars. At least once a year, once every couple of years, we'll get a comet that might be at 7th or 8th magnitude, and you might not be able to see it with your naked eye, but you can see it in binoculars. So, of course, the really showpiece comets like Neowise or Hale-Bopp or Hyakutake, they were great in binoculars, but they were good with the naked eye too. But there are many more comets that are great with binoculars. Now, what about some other planets? What about, say, Uranus and Neptune? Or what about some of the brighter asteroids like Ceres, Pallas, Juno, or Vesta? Well, sometimes in astronomy, the challenge is just to find the object and say you saw it. So you can see Uranus, Neptune, and some of the brighter asteroids with binoculars, but they're nothing more than dots in your binoculars. Heck, they're really not much more than dots in most amateur telescopes. But again, sometimes the challenge is just to say you saw it. It's a observing challenge. Now, what about everyone's favorite former planet, Pluto? No chance. Sorry. It's too faint. Maybe with the Fujinons, but no other binocular can do it. That's you really got to have a good sized telescope, at least an 8-inch telescope to do it. Now, before we talk about deep sky object targets, let's talk about Charles Messier first, because many beginners ask, what is with all these M objects? Messier 31, Messier 95, or what about all these NGC or IC objects? What is with all these crazy, numbers and letters? So, of course, the M in M31 stands for Messier, and they were named after Charles Messier here, who, as you can see, was the ferret of comets and the founder of probably the most famous deep sky catalog in astronomy. So let's learn a little bit about him first and talk about his catalog next. So Charles Messier was born on June 26, 1730 in Bedon, France, to a wealthy family. He was the 10th of 12 children, but 6 of his brothers and sisters died while he was young, so he never really knew them. And in fact, his father died in 1741, which left the family in kind of dire straits financially. So his older brother, what was his name, Francois or something like that, or something along that line, kind of took over as head of the family. So what drew him to astronomy was seeing the great six-tailed comet of 1744. And again, that inspired him to become an astronomer. But he also saw an annular eclipse in July of 1748. But from his location in France, it was actually a partial eclipse. But viewed in the proper path, it was an annular eclipse. But that probably inspired him more in astronomy as well. Then in 1751, when he was about 21 years old and had to get a job, he was hired as a draftsman and clerk by the astronomer of the French Navy, Joseph Nicolas Delisle, mainly because he was trained to be a clerk by his older brother, and he had really good handwriting. So that's why he was hired in that position. And of course, it helped that he liked astronomy too. And then the time came to look for the return of Halley's Comet in 1757. And this was a very important moment in his life. Now, of course, Halley's Comet comes back every 75 years now. But this apparition in 1757 was very important because this was the first predicted return of Halley's Comet, because Edmund Halley realized that it was the same comet that kept coming back into the inner solar system every 75 years. And he predicted the comet would return in 1757. He knew he wouldn't live to see it. And in fact, he died like 20 years earlier. So he told astronomers of the day to look for it. So Charles Messier wanted to be the first to find it. And he didn't find it until June 21st, 1759, because Joseph Delisle had made a miscalculation, and Messier was looking in the wrong part of the sky. But it was a German farmer, Johann Georg Palsich, that recovered the comet on Christmas Day, 1758. But Messier didn't hear about it for several months, because they didn't have Facebook or Twitter back then. So here's where Messier did most of his observations. This is the Hotel de Cluny. And here's a little inset picture of what the hotel looked like in Messier's day. This little structure up here was the observatory that Messier worked from. And you can see it's this tower right here. And of course, the observatory no longer exists. So right up here is where Messier did most of his work. So eventually, Delisle retired, and he became the chief astronomer at Marine Observatory in 1759. And of course, it was with Halley's Comet and not finding it first that inspired him to begin a kind of new career of searching for comets. Back then, he got paid to look for comets, but of course he did other things too. So he independently discovered 13 comets, 20 in all, but 13 of these were independent discoveries. So that's where King Louis XV nicknamed him the Comet Ferret. So that's where he got that nickname. But then in 1759, while observing near the southern horn of Taurus the Bull, he found something that he said was a little too bright, too white, and top elongated to be a comet, which had always appeared to me almost round. And he began to realize that this was not a comet because it didn't move. It was fixed in the sky. So it was one of these nebulae. And back then, pretty much anything fuzzy through a telescope was considered a nebula. The general idea back then was that all nebulae could be resolved into stars through larger telescopes, but that turns out not to be true. And also Messier, he mainly used a 4-inch telescope, with a 4-inch lens, a 4-inch refracting telescope. So he began to look for objects that look like comets through his telescope. So by 1764, Messier, along with his friend and assistant, Pierre Méchain, accumulated a number of false comets and began making a list of them. So for Messier, this was a list of objects not to confuse with a comet. His goal was not to make a list of cool deep sky objects to observe, but for us today, that's what it turns out to be. So that's what the M in, say, M31 stands for. So most people consider there are 110 objects in the Messier catalog, but not everyone agrees to that. Some say there's only 109, but there are many oddities to the Messier catalog. So let me just walk you through a few of them here. M24 is not exactly a deep sky object. It's really a star cloud in the Milky Way, in the constellation Sagittarius. M40, there it is. That's just an optical double star. It's not even a true binary. So that's kind of odd. But to him, it looked fuzzy through his telescope. M47 and M48 He had, I think, like sign errors. Instead of a plus sign, he had a negative sign, for example. So M47 is probably NGC 2422, a open cluster by that name or designation. M48 is probably the open cluster NGC 2548. But they are true deep sky objects. And again, they're probably just sign errors that were really easy to figure out. M73 here, that's just an asterism of 4 stars. They're not even related. Again, there was an error with the coordinates for M91. There it is. And that's probably the galaxy NGC 4548. Now, the big controversy is with M102. Even Pierre Machain said that M102 is just a duplicate of M101. But many weren't convinced of that based on things that Messier wrote, but the mystery was never solved in their time. So some people omit M102 from the list altogether, but many say that M102 is actually, wrong one, is actually NGC 5866. And another great mystery is how come Messier excluded the famous double cluster? Because with your eyes, it does look like a comet in the sky. So that's a mystery why he didn't include some of the more popular non-Messier targets like the double cluster. And even objects like the Orion Nebula or the Pleiades, he knew it wasn't a comet, but he just added it to his catalog to flush it out. Because the first version of his catalog had 45 objects, so he added M45, the Pleiades, to kind of make it a nice kind of round number. So the catalog kind of took on a life of its own too. But even though it might be a list of non-comets, it is really a list of the 110 of the best deep sky objects in the sky, with a few exceptions here and there, especially M40 and M73, because those are pretty boring. So Messier died at the age of 87 on April 12th, 1817. And here's his grave in Paris, France, which is at the Père Lachaise Cemetery. It's in dire need of renovation. I did see there's an Indiegogo campaign right now to raise funds to refurbish the grave here, but who knows if it'll ever get done. But that's where Messier lies at rest today. All right, now how about those NGC objects or those rarely observed icy objects? We should mention those for a beginning amateur astronomer. So, of course, NGC is the new general catalog, and it was compiled by John Louis Emile Dreyer in 1888, and it contains 7,840 deep sky objects in all. And it's the NGC catalog, or the NGC, is based on the work of William, there he is here, and Carolyn Herschel, the brother-sister duo, and of course, John Herschel, and their catalog of nebulae and clusters of stars, which was first published in 1786. It does include some objects south of the celestial equator that were observed by, again, John Herschel and James Dunlop here, again, from the southern sky, because most, they didn't go too far south, though. But John Herschel and James Dunlop did. Now, the original NGC catalog, compiled in 1888, did have supplements that are called the index catalog. So this is, again, supplements published by Dreyer in 2 volumes in 1895 and 1908, and it contains an additional 5,386 objects. But the NGC catalog, and probably the IC catalog, but the NGC for sure, had numerous revisions. Jack Solentek and William Tift came up with the first revision in 1973. Roger Sinnott from Sky and Telescope published 2 in 1988 and 1993, but more recently, Wolfgang Steinicki published some in 2009 and as recently as 2019, with 13,000 957 objects in all. So there's a lot of stuff to observe out there after you get done with the Messier catalog. There's always something new to see. So now you know what the M, NGC, and IC catalogs are all about. So let's talk about some deep sky targets to observe with binoculars. It's kind of a top 10 list, but there's actually more than 10 here. So, but there are 10 slides. So it's kind of a top 10 list. We'll start in the spring constellation of Cancer the Crab, which, and again, by spring constellation, that means it's observable in the evening in the spring. So M44, or Messier 44, the 44th entry in Messier's catalog, is known as the Beehive cluster, but it's also known as the Persepi, which is Latin for manger, and it's located just west of Ascellus borealis and Ascellus australis. It's this little faint patch of light right there. It's located about 525 light years away and has a diameter of about 95 arc minutes. So it's over a degree across, over 1.5 degrees across. Now, it contains about 1,000 stars in all, but through binoculars, you can see about 20 stars, at least in 10 by 50 binoculars. The field of view here is for 7 by 50 binoculars, but in 10 by 50s, I've counted about 20 or so. So this is the field that you would see with 7 by 50 binoculars. Of course, you wouldn't see the constellation lines. If you do, if you see these lines, please consult a doctor. Now, here's a non-Messier object, the North America Nebula, NGC 7000. It's often incorrectly called the North American Nebula, but nope, it is the North America Nebula. This is located 3 degrees east of Deneb. Here's Deneb, the tail of Cygnus the Swan. And it has a diameter about 120 arc minutes across. That's 2 degrees. And it's about 50 to 100 light years across in reality, you know, in physical size, and it's about 3,000 light years away. Now, here's the field that you would see in 7 by 50 binoculars, but remember, or know, that you can never really see color. Pretty much all deep sky objects, especially nebulae and galaxies, they look like glowing pearl gray light. So our eyes just aren't sensitive enough, or the colors aren't bright enough to register in our eye. So you never get to see color through binoculars or a telescope, at least with most deep sky objects. Now, of course, you can see why it's called the North America Nebula, because you can see Florida, you know, the East Coast, the West Coast, Mexico. Of course, Michigan's covered in clouds, haha. But nearby, if you have really dark skies and good eyesight, you can see a bonus here. This is one of those index catalog objects. This is IC 5070, the Pelican Nebula. And with binoculars, you might not be able to see the color, but you can see the shape. That's what's really cool. Now, here is the mystery object. Here's the, because we don't know why it wasn't added to the Messier catalog, considering some of the stinkers he has in there, like, you know, M40 and M73. But here's the famed double cluster in the constellation Perseus. The two clusters are NGC 869 and NGC 884. In the close-up view here, I forget which is which, so forgive me. But the double cluster is also known as H and Chi Persei. This is about 60 arc minutes across, both clusters together. So both clusters are about 1 degree across. It's about 7,500 light years away. And in total, it has about 300 members, but you won't be able to see that many in binoculars. It can really vary how many you can see in binoculars. So there's one cluster there, and there's another cluster there. So with binoculars, they're really squeezed together there. And one thing that I've noticed when observing the double cluster with binoculars that I've never seen referred to anywhere else is that with 7x50 binoculars, I don't see it here really, but if you look really close in the real sky, the double cluster is like the slash in a large letter Q. I think it goes off the picture here because it's pretty big, but there's like a large group of stars in a big O, and the double cluster makes the slash in the Q. See if you can find that. Again, I've never seen anyone refer to that in any writing anywhere. Now, here's a cool challenge. It's pretty easy to spot in binoculars from very dark sites, I mean really dark sites with no moon and no light pollution and good eyesight. You can see it with the naked eye. So here we have the Triangulum galaxy M33 because it's in the constellation Triangulum. Some people call it the Pinwheel galaxy, but M101 is often called the Pinwheel galaxy, so that name is taken. Now, this galaxy is located 7 degrees southeast of Merak, which is this star here, the the middle star in the lower arc of Andromeda here. So go 7 degrees southeast, and you'll find M33. You can also go 4 degrees northwest of this star here, which is Alpha Trianguli, the brightest star in the constellation Triangulum. Now, this galaxy is about 60,000 light years across and 2.73 million light years away. And it contains about 40 billion stars. But in binoculars, it's just a smudge. But again, remember, like with Uranus or Neptune or asteroids, sometimes the challenge is just to say you found it and you saw it. So it may not look like much in binoculars, but hey, it's 2.7 million light years away. That's pretty good for a pair of binoculars. Now here's our 2 for the price of 1, the Butterfly and Ptolemy cluster, or M6 and M7, because with 7x50 for sure, but maybe 10x50, you can observe both at the same time. So M6, which is the smaller of the two, this is M6 up here. This is called the Butterfly cluster, and all it contains about 60 stars. You can see maybe a third of that in binoculars, but again, it depends on the binoculars, the eyesight, and the conditions. It's about 25 arc minutes in diameter, so smaller than the moon, but still pretty good size. And it's about 1,600 light years away. M7 is known as Ptolemy's cluster. It contains 80 stars in all. It's about 80 arc minutes across, so larger than a degree. And it's a little closer at 980 light years. And fun fact, it is the southernmost Messier object. There's none further south than M7 here. But you can see both with the naked eye, but they are great sights in binoculars. Now, these are 2 of my most favorite targets in the entire sky. Every time I get a new pair of binoculars or telescope, I observe at least M8, or if I get a new camera, I take a picture of it because I love the Lagoon Nebula, which is M8, but the Trifid Nebula, M20, is pretty good too. Now, all you have to do is go 6 degrees north of the spout in the teapot here, and that takes you to right between M8 and M20. So just a little quick star hop from the spout of the teapot there. Remember, this is the teapot asterism in Sagittarius. Now, they're both related. They're both part of the same molecular complex, and they're about 4,100 light years away. Let's zoom in there. So M8 is about 90 by 40 arc minutes. So on its long axis, kind of going east-west here, it's more than a half a degree across. And it measures in its true diameter about 110 by 50 light years, which is much larger than the more famous Orion Nebula. Now, M20 is about 30 arc minutes across, about the size of the full moon, and its true diameter is about 15 light years across. They are both emission nebulae, But the Trifid Nebula has properties of, it has a dark nebula and a reflection nebula as well. But you can really only see the emission nebulae part in binoculars. But again, they are splendid sights in binoculars. You can see the shapes, but you can't see the colors. Sorry. The fault is not in the sky, but in ourselves. You know, our eyes just can't do it. Now, here is the Andromeda galaxy, M31. Andromeda is often considered the most distant object you can see with your eyes alone, but that's not really true because M33 is a little further away, and I've seen it with the naked eye from dark desert sites plenty of times. So there's even another galaxy, NGC 253, that's even more distant, and under really good conditions, you can see that with the naked eye, but I've never done that. So M31, the great galaxy in Andromeda, it's 4 degrees southwest of Mu Andromeda, the middle star in the upper arc of Andromeda. So just a short star hop from there. And of course, the Andromeda galaxy is 2.5 million light years away. Its true size is 130,000 light years, but from Earth, it's about 3 degrees across. But it may not sound like much, you know, 3 degrees, but 3 degrees is 6 full moon diameters. So it is big. It does contain up to 1 trillion stars, and it does have 2 satellite galaxies. But first, here's the Andromeda galaxy. Through binoculars at a dark site, you should be able to make out a good chunk of the disk here. If you do have light polluted skies, you might only see the central nucleus here. But if you see a bright dot, that is M32. But more challenging in binoculars is this galaxy here, M110. M32 and M110 are both satellite galaxies to Andromeda. M32 is doable because it's so bright and dense, but M110 here is more challenging. But Andromeda is a grand sight in binoculars. Now, you can't view both of these objects with 7x50 or 10x50 binoculars, but I bet you could with 2x54 binoculars, you know, those constellation binoculars. But here we have the Hyades and the Pleiades. The Hyades is like the nearest cluster to Earth, period. And it's the V-shaped group of stars here. There's the bright star Aldebaran, but Aldebaran is not a true member of the Hyades. It's closer to us than the Hyades. But you can look at the Hyades with binoculars. It's really big, about 330 arc minutes, or about 5.5 degrees. So it's pretty large in the sky, you know, compared to the moon anyway. And then up here we have the famous Pleiades, the Seven Sisters, or Subaru, as they call it in Japan. And zooming in here, there are over 36 stars you can see in 10x50s. So you can go from the Seven Sisters to over 36 stars with 10x50 binoculars. You can maybe see 300 stars in larger binoculars. So here I only show the Pleiades up close. So here's one favor I want to ask of you now. Now, you see this little chain of stars here, this little line of stars? For many, many years, I've been trying to convince people to call this the Bell string, you know, because my name is Richard Bell. So, if you would please do me the favor, if you ever write about this cluster, the Pleiades, just mention this little line of stars is called the Bell string, and send me a copy because I would greatly appreciate it. I'm trying to get that to catch on. I mean, it sounds very astronomical, doesn't it? You know, string theory, Bell string. I think so. Okay, so here's another great sight in binoculars, M42, M43, the Orion Nebula, 2 objects because they're part of the same molecular cloud. The Orion Nebula is easily found in the sword of Orion. So just go to his belt. Hanging from his belt is a sword. And if you look at the sword with your eyes alone, you can see it's glowing a bit. But here's the view in binoculars. And yes, in binoculars, you can make out the shape very clearly, just not the color. So the Orion Nebula is about 1,344 light years away. It is an emission nebula, a region of star formation, but what makes it so special, besides the fact that it's really cool to look at, is it is the nearest large region of star formation to us. There are closer regions, but this is the nearest big one. In its true physical size, it's about 24 light years across, but it measures 65 by 60 arc minutes. So over twice the size of the full moon. So it's good size. And number one on our list is easily the Milky Way itself. If you just want to go outside on a clear night, especially in the summer, no chart, just you and binoculars in the sky, just look all up and down the Milky Way, and you can rediscover many of these objects and more on your own. It is so much fun, especially when the conditions are really, really good. I mean, it is a galaxy, so it technically is a deep sky object. It's just the closest galaxy to us because we live in it. Okay, so the next thing I want to talk about are our Astronomical League observing programs. So these are fantastic for beginners especially, and even more advanced amateur astronomers, because one way to maintain your enthusiasm for getting out under the stars is to have a long-range viewing goal or plan. So Astronomical League observing programs do that by motivating and directing your viewing. It gives you something to work toward. So programs are available for the unaided eye, binoculars, of course, and telescopic observers of all skill levels. Now, of course, you have to be a member of the Astronomical League to participate in their observing programs, or a member of an affiliate club. Now, of course, the Kalamazoo Astronomical Society is an affiliate member of the Astronomical League, so our members can work on observing programs. But if you're part of another club, you know, perhaps very likely, they are also a member of the Astronomical League. You can join the AL directly, but it's usually, you know, cheaper to join as part of an astronomy club. So I'm just going to mention the ones that are good for binocular viewers because that is the topic for today. So the very first observing program I did way back in the 90s, the 1990s, is the Binocular Messier program. All you have to do is observe 50 of the 110 Messier objects with binoculars, because they consider M102 a true object. The next is the Deep Sky Binocular program. You observe 50 non-Messier deep sky objects. A lot of those are pretty faint from my memory. So the binocular one is the Binocular Messier is a lot more fun to do, but just for another project, you know, to learn more about where objects are in the sky, there's the Deep Sky Binocular one too. It's a bit more challenging as well. For you moon lovers out there, there's the Lunar Club. There's, I believe, a couple of them now, but the original version, the one that I did years ago, is 1/3 naked eye, 1/3 binoculars, 1/3 telescopes. So if you like looking at the moon, there's an observing program for you. For you younger observers out there, there's the Sky Puppy program, which is kind of a collection of various objects for young observers to look at. It does include targets for binoculars. As more general program, there's the Observing Sampler, which many of our members done. I have not done this one. The Object List 2 is done with binoculars or telescope. And then if you live under light polluted skies, like I'm sure most of us do, there's the Urban Observer, where you can observe 100 objects under light polluted skies. In fact, you're required to observe these from light polluted skies. That's the whole point of the Urban Observer Award. So if you complete a Astronomical League observing program, you get a certificate and pen. So for those of you going for your certificate for the lecture series, You know, you can earn even more certificates by doing Astronomical League observing programs. It is a great way to broaden and build your observing skills and resume. So I strongly recommend you do one.